second question, the snowboarder is approaching the ramp with an initial velocity of 3.2 meters per second. The ramp forms an angle with the ground of 40 degrees, and these are the givens that we already know. And what we're supposed to do is to find the snowboarder's maximum height. And to do that, we will use one of the big five equation, Vf square equals Vi square plus 2AD. And we have to use Vi times sine 40 degree to find VIY, so the velocity in the y direction. And I will explain this using a small diagram. This here is the ramp. It forms a 40-degree angle, and the snowboarder approaches it at 3.2 meters velocity to a direction like this. It's a bit slanted, and to find the y direction, we have to find this length here, so the y direction, which is upward. And we have to do a component, which we use the initial velocity times sine 40 degree to find the magnitude of the velocity of the y direction. And from the calculation, the velocity is 2.06 meters per second. And then we plug our equation in. Vf square equals Viy square plus 2a times d. And the V final is 0 because at the maximum point you stop. You reach a sudden stop, like you stop here. For example, you travel from the bottom, at the top you stop when the force of gravity equals to your initial speed. And these two are equal, and you reach your equilibrium, which you stop here and you do not move for a slight second, and you begin accelerate downwards and you go down here. So the velocity at the max height is 0. VIY we already know, 6 meters per second, plus 2 times A. A is 9.8 because the only vertical force that applies is gravity. So the only vertical force that applies to any object in air is gravity, and it's pulling you down. So it's negative 9.8. Because up is positive and down is negative, times d. And 0 equals 4.24 plus negative 19.6 times d. And we move this to the other side to isolate for d. Negative 4.24 equals negative 19.6 times d. And we divide 19.6 to this side. So from negative 4.24 divided by 19.6 equals to d. And 0.21 equals to d. So we'll write a therefore statement. Therefore, the max height the snowboarder reaches is 0.21 meters. For the second part, we're looking for the maximum distance the snowboarder traveled horizontally. And we're given the same information as the previous question. And that is the initial velocity of the snowboarder is 3.2 meters per second. The angle of the jump is 40 degrees. And in this question, the displacement in the y direction, delta dy, equals 0. This can be clarified using a simple diagram. Here is the point where the snowboarder starts his jump, and he travels in the projectile motion and comes back to the ground again. It's the same height as before he has jumped. Therefore, the displacement is 0. And now we will use a Big 5 equation to solve for t, which is essential for us to solve the equation. So 0 equals vi sine theta. The sine theta here symbolizes it's the y direction. Delta t minus half a t squared. The a here will be replaced by g because the only vertical acceleration is g. And we'll isolate for t. T equals 2 vi sine 40 degrees divided by 9.8. And this is the equation. Now we're going to find displacement in the x direction. dx equals vix delta t equals vi squared 2 sine theta cos theta divided by g. Now the vi squared here is delta t's vi, which is 2 vi sine 40. Delta t has a vi here, and vix is another vi. The two vi multiplied together equals to vi squared. The 2 here is the 2 in front of vi, and the sine theta is the sine theta in delta t. The cosine theta is in vix because it's the x direction, and the 3.2 we're given is the combined direction. We have to do a component of each to figure out what's the velocity of the x direction and what's the velocity of the y direction. Therefore, we use cos to find x and sine to find y. And that explains the cos theta. And the g is the 9.8 here, which is the acceleration. So basically I just changed delta t into this equation here and multiplied it by this equation. Okay, and then we will solve. And v initial square equals 3.2 square times 2 sine 40 cos 40. And equals to 10.24 times 1.02 divided by 9.8. And just let me add it in here. And this will give us 10.43 divided by 9.8, which is 1.07 meters. And therefore, we can say that the maximum distance the snowboarder traveled is 1.07 meters. In the last question, we're trying to find the final speed of the snowboarder. However, we do not need to actually calculate that because of the conservation of energy. As many of you would remember, 1/2 mv squared I plus mghi equals 1/2 mv squared f plus mgh(f). This is what I taught in the last class, and if you paid attention closely enough, you would understand this. And because the two heights equal, mgh equals to mgh, and these are cancelled. And therefore, mvi squared equals mvi squared, because the mass equal, and half can be cancelled out, and vi squared equals vf squared, and therefore vi equals vf. And therefore, the final speed of the snowboarder is the same as his initial speed, 3.2 meters per second.